Hi there, physical science students. This presentation is a follow-up to Activity 6, the heating curves of water, and the big ideas that we hope that you've learned from that activity. This presentation is divided up into three parts. The first part discusses the states of matter, the second part discusses phase changes, and the third part talks specifically about heating and cooling curves of water. So we're going to get started here talking about the states of matter. And so by the time we're done with this presentation, you should be able to explain to us how particles move in solids, liquids, and gases and be able to compare and contrast those. You should also be able to describe a process of changing states of matter as either being endothermic or exothermic. So we're going to start by discussing this picture here on the screen. As you can see, we have a solid on the left, a liquid in the center, and on the right, we have a gas. If we take a look at this picture, we can see that the particles moving in each of these containers are moving in a very different way. Our solids are moving, they're vibrating in place, but they're staying in the place that they're at. They're not moving past each other. They're not filling up the container completely. All right, they're packed closely together. As we move from solid to liquid, we can see that the particles are changing a little bit. This change occurred because these particles have absorbed energy from the outside, and we'll talk about that a little bit more. We can see that these molecules are moving much faster. They're sliding past each other, but they're still staying toward the bottom of our container. They're not filling up the container completely. And then in the gas phase, we can see that those particles are moving around with much more energy. They're moving much more quickly, and they are filling up all parts of the container. This process of going from solid to liquid to gas is called an endothermic process. In this process of moving from solid to liquid to gas, energy is increasing. This might occur because we are heating up this substance. We're adding energy from the outside, and that's why it's called endothermic, taking energy in. This process requires an absorption of energy from the outside. And the result is, if we were to take the temperature of the solid, the liquid, and the gas, we would see that the gas would have the highest temperature. The result is an increase in temperature. If we look at the opposite direction, we can see that as we go from gas to liquid to solid, that the amount of energy or the movement of our molecules is much less. In order for this to happen, energy has to be released. And that often occurs when we see a decrease in temperature. This might happen if you put a glass of water, liquid water, into the freezer and it turns into a solid ice cube. Your freezer actually acts to take away the energy from the water, and that is called an exothermic process. In the next section, we're going to talk about phase changes. These phase changes are called melting, freezing, condensation, evaporation, boiling, sublimation, and deposition. So let's go ahead and take a look at this diagram. So in this diagram, we're going to talk about we're going to identify those phase changes for each of these processes. So for the first one, let's take a look at what happens when we have a solid that is going to go right from solid phase all the way over to gas phase, so it skips that. This process is called sublimation. Can you think of something you have seen in your life where sublimation has occurred? Does anybody know what this is a picture of? This is dry ice, often seen around Halloween. Dry ice goes directly from the solid phase directly to gas phase, totally skips the liquid phase. That's called sublimation. All right, if we go from solid to liquid, we're all very familiar with that. That's melting. We've seen a melting of an ice cube. From liquid to gas, that's vaporization. That's where we go from liquid to gas. Maybe when we boil water, we see the steam given off by it. Those three are all endothermic processes. If we go the other way, we're going from a gas to a liquid. That's called condensation. You've probably experienced this when you've had an icy cold drink and the outside of your glass becomes wet. That's condensation. That's water in the air outside of your cup getting cold and condensing on the outside of your glass and turning into a liquid. Going from a liquid to a solid is freezing. So freezing an ice cube in your freezer, that would be that process. And you can actually skip the whole liquid phase on this one too. That's called deposition. Deposition, you've probably seen this happen on a car window in the wintertime where you come outside and it's got the frost on the window. That's because it's so cold that the water that's in the air, when it comes in contact with a cold car, immediately freezes into a solid, never goes into liquid phase, and it can form these really beautiful crystals. All right, last section that we're going to talk about are heating and cooling curves. All right, so on this one, you are going to be required to identify where melting, freezing, condensation, evaporation, boiling occur on a heating and cooling curve. You're going to need to talk about the significance of potential energy on a cooling curve, the significance of kinetic energy, and how to actually appropriately graph the data. All right, so two key terms that are important on any heating or cooling curve are melting point and boiling point. Melting point is the point where we have a phase change occurring where solid ice is becoming liquid water. Boiling point would be where our liquid phase is becoming a vapor. That's where vaporization is beginning. So let's take a look at an example of a heating curve with melting and boiling point. So we take a look at this graph. This is the heating curve of water. What is the melting point of water? What is the boiling point of water? If we take a look here, the melting point of water is 0 degrees Celsius. This is the point where solid water starts the transition into liquid water. And you can see that this is a plateau on this line, a flat line. It takes some time for all of that ice to melt, and during this time, there is no increase in temperature. Okay. At this point, all of the ice has melted and it is all liquid. And that's where we begin to see the rise in temperature begin again. On this slope, all of that water is in liquid form in the beaker. It stays in liquid form until we reach the boiling point. This occurs for water at 100 degrees Celsius. At 100 degrees Celsius, that liquid water starts to become vapor water. Some of it's still liquid water, but some of it's starting to become vapor water. And that continues until we get to this point. At this point, all of it is vapor water. What do melting point and boiling point have in common? Those are points where we have a transition or a change in state occurring. They both signify a change in state. Solid to liquid for melting point, and for boiling point, that change is going to be from liquid to gas. There is no increase or decrease in temperature at that point. All right, so let's take a look at the bullets for this. Similarities between melting point and boiling point for water. Both start at the beginning of a plateau, that's the flat line on your graph. Both occur at a specific temperature in Celsius. So for the Celsius scale, that's 0 degrees Celsius and 100 degrees Celsius. Both mark the beginning of a phase change, and both occur when heat is being used to change the phase instead of change the temperature. This bottom one is very important. Melting point and boiling point are indicating the beginning of a phase change. There is no temperature change occurring at that point on our heating curve. When we look at a heating curve, we're seeing that the phases are changing from solid to liquid to gas or vapor. As you can see, energy is required in order for this change to occur. So a heating curve is an endothermic process. It represents an endothermic process because heat is being added. At what temperature on this heating curve do the atoms have the least amount of kinetic energy? On this graph, you're going to identify the phase changes represented by A, B, C, and D. Identify whether this curve represents an exothermic or an endothermic process. Pay attention to the axes on the graph. Does this curve represent an exothermic or an endothermic process?